Okay, let's look at the solution. So a hat is minus 1, v hat is minus t, y hat is minus 1/2 t squared plus 1. Okay, so this particular event, what do we know about it? Well, y starts at 1 and ends at 0. So, and we want to, in our Python, in Spider, start a new section and call it, what should we call it? I don't know, solution. We may change that name. Okay, so what I want to do is set up things to plot a and v and y versus time. And so what I'll do is say, well, what's the natural independent variable here? It's time. So I'm going to say t underscore hat because the hat is dimensionless, and I'm going to say is equal to linspace 0 comma square root of 2 comma 150. Okay, so let me explain that. Let me run it. And what does it do? It says linspace is not defined. Oh, that's because I need to import linspace. So I'm going to go back up into NumPy and import linspace, and then hit run again, and it runs. And if I look here, by the way, I meant to mention in the other video, a star 3.27. Actually, that's the acceleration due to gravity. What happens if I put little m equal to 0 and hit and run it? A star is 9.81. What if I put 9.0 and run it? A star is 0.5. So this is giving me the net acceleration, and the closer big M and little m are together, the lower is the acceleration. Okay, back to t hat. So we know, if you're familiar with MATLAB, linspace is going to create, let's look at what time is. T hat is an array of, so it created an array. Linspace creates an array, and that's different than a list, but of 150 points. So that's why I put the 150 here, and it goes from 0. And in the console, I'm going to type in t underscore hat square brackets minus 1 close square brackets, hit enter, and it's 1.4. That's the value of square root of 2. So a couple of things. Python, when you're accessing elements of an array, uses the square brackets, not the circular brackets. What if I do, and I make this mistake all the time, the minus 1, this should give me something funny. It's not callable. So I don't know what that means, but it's an error, and it's because I used the regular parentheses, not the square brackets. So what t hat minus 1 with the square brackets is saying, look at the element minus 1. At minus 1 is the last element. Minus 2 is the second to last element. If I look at t hat, and the indexing in Python starts at 0. So t hat 0 is 0. That's an important detail to get. The reason I chose square root of 2 for t hat to go to is look over here at y. Now we know y is going to start at 1 when time is 0, and as it falls, it's going to hit the ground. When it hits the ground, y as it's defined is going to be 0. So if I set this equal to 0 and move t hat over here, and I have the 2, and then I take the square root of 2 is going to give me the time when y is equal to 0. So I've now defined my independent variable, and then now I can do a hat is equal to, now it's a constant value, but I want to have 150 points or however many points I specified. I'm going to actually change something here. Instead of saying points equals 150, and then put points in here, and then I'm going to say a hat is equal to minus 1 times ones in parentheses len t hat, and I'm going to hit enter, and I'm going to get an error because ones is not defined. What is ones? If you're familiar with MATLAB, ones ones is a little different in Python than MATLAB, so the details you got to be careful of. But if just to show you, so I needed to put it in NumPy, but then I say ones parentheses 5 gives you an array of 5 ones, and then I multiplied it by minus 1 because it equals minus 1. So now I can just to sort of warm up, I can jump ahead and start. Well, I'll hold off. I was going to plot it, but let's go through the whole thing. And then notice that this does, so it does term by term without the dot star equal like you use in MATLAB. So v hat is minus t underscore hat. And I should be putting in, these are dimensionless, so it's dimensionless velocity, dimensionless acceleration, dimensionless time. And I'll just put in a comment here, number of points to plot. I'll put in my comments here. T star has units of second, and it's the characteristic time. And notice that y equals 0 when it's equal to square root of 2 times t star. I could have redone my non-dimensionalization and defined things so that I get rid of that 1/2 t squared, but I didn't. Characteristic speed or velocity. Remember, what's the difference between speed and velocity? Speed is a scalar, velocity is a vector with magnitude and direction, the magnitude being speed. Now, in this problem, because it's deliberately chosen to be a simple one, a is a constant, and then we have these simple solutions. So mostly we're just trying to teach principles and MATLAB scripting. Okay, y hat, the last one, minus t, I'm gonna t hat up hat squared divided by 2 plus 1. I'm gonna get an error, and this one drives me crazy. And you'll make this mistake, and this is why you want to save it and run it. So I try to figure out what the error is. If you look here, it's telling me there's an error. ufunc bitwise.xor not supported for int type, and I'm like, for the life of me, I can't figure it out. I don't know what it's doing, but now that believe me, this is Python uses star for exponentiation, and the up caret means something very, very specific. I don't know what it is because it's more advanced, but if I run that, then everything, so it ran through, it created, so now I have my solution is all sitting there. The last thing I need to do is to plot it, and so I'll do that in the next video.